Okay, in this video we're going to talk about activity 8.1, which is going to deal with complex numbers. So complex numbers all deal with square roots and what we can and can't take square roots of. So back in the day when you were first learning about square roots, we learned them as what number multiplied by itself equals the number under the radical. So we would say that the square root of 25 is equal to plus or minus 5. Because 5 times 5 is going to give me 25, and negative 5 times negative 5 is going to give me 25. Then we came to an interesting question that said, what's the square root of negative 25? And by definition of square roots, we had no answer. We would say no solution. There is no such number, because if I multiply something by itself to give me that negative 25, I'm never going to be able to get a negative number, because a positive times a positive is a positive, a negative times a negative is a positive, so I can't ever multiply something by itself to get a negative number. Until now. We're going to be working with things called imaginary numbers. And imaginary numbers allow us to take the square root of negative numbers. So the definition of an imaginary number, the basic imaginary number, is the square root of negative 1. And what we are going to call the square root of negative 1 is just I. And that just stands for imaginary numbers. So we have a couple of things that we can think about. We can write it as square root of negative 1 equals I. Or if we were to square each side, the square root and the square are going to cancel each other out. So negative 1 can equal I squared. So that square root of negative 1 is the basis for our imaginary numbers. And how we can use them is if we have something like the square root of negative, just say s, some variable s. How we would worry about that is we would think about the square root of negative 1 times s, which would be the square root of negative 1 times the square root of s, which would give us I times the square root of s, because the square root of negative 1 is s. So we have those properties of square roots where if we're multiplying, we can kind of break it up into multiple square roots. So we're going to try to pull that square root of 1 out and turn it into an I, and then deal with our square root from there. So we can look at a couple of different problems that are all going to deal with the square roots of negative numbers. So our first example would be something like the square root of negative 17. So we want to think about this as the square root of negative 1 times 17, which could be the square root of negative 1 times the square root of 17. And we know the square root of negative 1 is I. So we're looking at the square, or I, times the square root of 17. Now, square root of 17, we can't really simplify. 17 is a prime number, so we're just going to leave it at I times the square root of 17. We could also look at something like the square root of negative 9. So again, we want to think of this as negative 1 times 9, which would be the square root of negative 1 times the square root of 9, which would be I times the square root of 9. But now we're at a spot where we know what the square root of 9 is. We know the square root of 9 is 3, so we can call this 3 times I. And then one more real quick example that we can run through. We can say square root of negative 12, which would be negative 1 times 12, which would be the square root of negative 1 times the square root of 12, which would be I square root of 12. Now 12, again, not a perfect square, but unlike 17, we could break 12 into two different numbers. So we can say 12 is the same thing as 4 times 3, which would give us the square root of 4 times the square root of 3. Square root of 4 we know is 2, so we can say 2i radical 3. So don't forget, if you have a non-perfect square, you can break it down and try to find perfect squares within your radical. So that's going to be the basics for imaginary numbers. Now we can talk about something called complex numbers. So as you can see on the screen, a complex number, or the set of complex numbers, consists of the real numbers and the imaginary numbers. So when we write them, we need two parts. We need the real part, which we're going to call A, and we're going to have the imaginary part, which we're going to call B times I. So if we think about the complex number 3 plus 2i, the real part is going to be the part that doesn't have the imaginary numbers. So our real part is going to be this 3. So 3 plus 2i, 3 is the real number, and then 2i, since 2 has the imaginary constant I, 2i is the imaginary part of that number. Now, we also can think about something like the number 5 as being a complex number. So we see the 5. The 5 would be the real part because it doesn't have an I. And right here, we can fill in that blank with a plus 0i if we wanted to, and that could be the imaginary part. Now, we're not actually going to have to write that in. We're going to keep 5 as our complex number, but the complex numbers is all of our real numbers and all of the imaginary numbers by definition. So 5 by itself is a complex number because it has that plus 0i. So one thing that we're going to be able to do with our complex numbers is graph them. We're going to graph them on what's called the complex plane. The complex plane is going to work and look similar to our Cartesian plane, our xy axis that we're used to, except that our horizontal axis, what we usually think of as the x-axis, is going to be the real axis, and the vertical axis, what we usually think of as the y-axis, is the imaginary axis. So if you look on the screen, we kind of have a dot on there, and how we're going to call this as far as our complex numbers is we're going to think about the real part first. So if you look, we go 3 over on the real axis, and then we go up 5 to a positive 5 on the imaginary axis. So since it's the imaginary axis, we're going to put a little I right there. So 3 plus 5i, and I'll go ahead and I'll change that to red to match the dot. So we can say that dot is 3 plus 5i. So we're going to go 3 on the real axis, 5 on the positive imaginary axis. So if we wanted to plot the point -2 plus 4i, we would go -2 in the real axis, and then up to 4i on the imaginary axis. So we have -2 plus 4i right there on our complex plane. We can also, just to make sure we kind of know what we're dealing with here, we can go 1 minus 2i. So that would be over 1 on the real axis and down 2 on the imaginary axis. So that would be our 1 minus 2i on the complex plane. So if you downloaded the video notes, there's a few problems that I want you to try on your own, so go ahead and try those. If you have questions, make sure you ask at the beginning of class because we will have a homework quiz.